So we're still working on talking about properties of amines. We have two more properties that we're going to talk about. The next thing that we're going to talk about is solvent extraction. And this is something that you have done in the lab, not with an amine, but with a carboxylic acid. So you've used this property before. I'm going to describe it. I'm going to talk about how you've used it, and then we'll talk about how it applies to amines. Solvent extraction is essentially when you are protonating. In the case of an amine, it is protonation of an amine. That the protonation causes it to become ionic, and therefore it becomes soluble in water. And this allows us to separate it from other organic substances. Now, you probably don't even remember doing this in lab because it's like, I think it's the first lab that we actually did. So this is, this is just kind of a side thing, not protonation of an amine. What you did in lab was take a carboxylic acid and you reacted it with a base, probably sodium hydroxide, and you deprotonated the carboxylic acid. And so when you had the carboxylic acid, it had some kind of big alkyl group on it. I don't even remember what it was. And it was soluble in organic solvent. So you probably had it dissolved in like ether or hexane or something like that. And then you added this sodium hydroxide and it created the deprotonated carboxylic acid. And that thing was, because it's no longer soluble in an organic solvent, it precipitated like immediately. You got like a big, massive amount of white precipitate. And because it was one of the very first things that we did in lab, it probably just looked really magical and you didn't really know what was going on. But you've done it. With amines, it's basically the exact same process, but because they are bases instead of acids, we're going to be reacting the amine with not another base, but instead with an acid. And I'm going to give you a really great real-world, everyday example of solvent extraction. So we're going to draw kind of a tricky molecule here. This molecule that I'm drawing is this beautiful bicyclic molecule. There's a carbon there. It's kind of an ugly, I made kind of an ugly ring. Remember, pH is phenyl. So this molecule that I drew, like I really want to fix this bond right here. This is cocaine. It's an amine, plus, it's also an ester. And this is the actual cocaine molecule that this is what you would get if you extracted it from the plant. This, because it's an amine, and one of the characteristics of amines is that they have a very bad smell. Like usually most of the bad smells that you smell, a lot of them are amines. They're the smell of death, decay, rotting, urine, in general, nasty smells, smell like rotten fish, things like that. Those are usually amine. So this thing smells pretty bad. And also another problem with this molecule, because it is an amine and it's a very large amine, it has more than 5 carbons on it. This is not soluble in water. Now, you might be saying to yourself, hey, I've snorted a lot of cocaine. It doesn't smell like dead fish. Or maybe you're saying that doesn't make sense because I snort cocaine and it travels through my mucous membranes into my bloodstream, so therefore it is water soluble. That you are correct. And that is because this molecule on the street is known as crack, or freebase, which is more of an 80s term. So the molecule that we call crack on the street is actually the cocaine molecule, which probably is making you wonder, what is cocaine then? I'll tell you, don't worry. So the difference between crack and freebase is just the purity. Freebase is more pure than crack. It's been purified. Crack usually has other stuff in it, like baking soda and grosser stuff. And crack, as you know, must be smoked, because it's not really effective to snort it because it's not water soluble. So the best way to get high off of crack is to smoke it. Now, a lot of people don't want to smoke crack. That's not classy. So if you get yourself some crack, you can go down to Home Depot and buy hydrochloric acid. Home Depot sells it. They call it muriatic acid. That's the common name for hydrochloric acid. And that hydrochloric acid just does a simple protonation of the nitrogen. Here's my opportunity to draw a better looking bicyclic. So we're just putting a proton on that nitrogen. No other functional group is going to be changed in this. And just by protonating that nitrogen, now we've turned it into a quaternary, and it's ionic. Just like that, it becomes water soluble. So it doesn't even matter anymore how many carbons it has. It is now water soluble because of its positive formal charge. This molecule professionally is known as cocaine hydrochloride, or cocaine HCl. That's a little dot that I made there. This molecule, for the most part, is odorless. Usually not completely, because of the process of synthesizing it in the garage or whatever. There's a little bit of a residual smell, but if it was pure, it wouldn't have any smell. This is water soluble, again, because it's been protonated. And this is the molecule that we refer to as cocaine. So when you go somewhere, 7-Eleven, and you buy some cocaine in the parking lot, you're actually buying cocaine HCl. And this, because it's water soluble, the most common way that people use this is to snort it. Because it's water soluble, you can snort it, and it passes right through your mucous membranes into your bloodstream and then does what it's supposed to do. So one of the really interesting things about the history of cocaine use, when cocaine became illegal, it was on the books illegal as cocaine, this molecule right here. And when people were getting arrested and in possession of cocaine HCl, their attorneys were able to actually get them off on those drug charges, because there was no law that said that you could not possess cocaine HCl. You could only not possess cocaine. So for a while, cocaine HCl, aka cocaine, was actually a legal drug. And they had to change the law. So the law now reads something like cocaine HCl. It has a whole bunch of other derivatives. And then at the end it says, and all of its derivatives. So they have, found a way to tighten that law up. But I think that's interesting. So the problem with cocaine HCl, when we do this protonation right here, and take it into our body in this form, that's not the way that Mother Nature synthesized the drug. Mother Nature synthesized it like that. And so that pure form of the cocaine, the true cocaine molecule, is the one that will get you the best high. So when you purchase cocaine HCl, sometimes people want to purify it, I guess. The process of purifying it actually makes it even dirtier. But they'll take a base, and baking soda, which has HCO3 minus, is the best base to use for this, just because it's very easy to get your hands on. And that will just very easily deprotonate the nitrogen. You can just do this by mixing a paste of baking soda and water, and then mushing that together with the cocaine HCl. And it'll be wet, so it needs to be dried out. And these days, because everybody has a microwave, they usually do that drying out process in the microwave. But you used to just do it on like your stovetop back in the day when not everybody had microwaves. And so when you do this in the microwave, you don't have any way of separating the products, the byproducts of this. So let's go back to cocaine HCl. This is going to have some chloride ion, the counter ion with the negative charge. So when you do this extraction with baking soda, you are going to have, like, you're still going to have those chloride ions hanging out in there. You have this, when you buy HCO3 minus, it's typically sodium bicarbonate. So you've got some sodium ions in here. And then you've got this H2CO3. Now that thing is going to usually turn into water and carbon dioxide, so that probably just leaves on its own. But there's no way of easily getting rid of these ions that are hanging out in there. So you've got these impurities in there. And this combination is what we call crack. Because it is, even though the molecule has returned to the pure form, you're still dealing with a mixture of the cocaine molecule plus all these byproducts of the protonation and then subsequent deprotonation. So it's dirty. None of these things that we're getting in the purification and then deprotonation process, none of them are toxic or anything. These are just regular everyday stuff that we eat all the time. But it's not pure, you know. So some people will further purify their crack with a solvent extraction. So they'll just mix the crack mixture together with ether or some sort of organic. And this would be like stuff you've done in the lab using a SEP funnel. So you could just take your crack, maybe put a little bit of water in there so that you're going to have a good organic / aqueous separation. Put some ether in there into your SEP funnel, shake it up, get 2 layers, drain out the organic layer. So your organic layer, and drain out your aqueous layer. Your aqueous layer is going to contain your sodium chloride, if you have any baking soda, all that type of stuff, and you'll throw that away. Your organic layer is going to contain your pure cocaine and ether, and that pure cocaine we call free base because it has become totally pure and it's just that free base. The ether, as you know, will just evaporate. And if you can be patient and wait for all the ether to evaporate, you'll end up with this nice free base cocaine. Some people don't have the patience to wait for all the ether to evaporate, so maybe they'll wait until it looks kind of dry and then they'll start smoking it. But ether is super flammable. So if you start smoking your free base too soon, you can end up with a bit of a problem. This is a sad person on fire. Make sure you always dry your cocaine. Give it plenty of time for the ether to evaporate. This whole thing right here, this interesting to talk about it in terms of cocaine and crack. This is not a process that's only used in illegal drugs. This is also used in many over-the-counter pharmaceuticals. So what you should do right now, just because it's interesting, go check your medicine, especially your over-the-counter cold and flu medicine, cough medicine, decongestants. You're going to find, when you're looking at your over-the-counter cold and flu medicine, you're going to find a lot of substances that have some sort of chemical name, and then it'll say .HBr or something HCl, or maybe the dot won't be there. Maybe they'll spell it out, something, something, something hydrobromic, or something, something, something hydrochloric. This is because this exact same process is very applicable for a lot of pharmaceuticals. A lot of pharmaceuticals are amines. They're not water soluble. They've got bad smell. They smell like urine and dead fish. And those are not things that consumers want. You don't want to have to smoke your Sudafed, and you don't want it to smell like a rotten fish. So the manufacturers will protonate the cold medicine with hydrochloric acid or hydrobromic acid. Those are the two most common. And they turn it into this water-soluble form that is much more consumer friendly because it doesn't have a smell. And you don't have to snort your Sudafed. You can just ingest it. But nonetheless, it makes it a much more pleasant experience for the user. So go check it out.